In the closing minutes, I want to go back to my work in early life and talk about sugars, good sugars and bad sugars in early life, and some of our work on formula. And we kind of stumbled into this in one of our studies. We didn't go looking for this particular finding, but we're in the middle of this birth cohort study. We've been following a cohort since birth. They're now all turning 6 years of age. But I'm going to show you data from the first 2 years of age. And it turned out that these infants during the first year of life kind of fell into 3 different buckets. They were either predominantly breastfed, or they were predominantly fed a traditional formula, which was a lactose-based formula. Or many of them, in fact, about a third of these women, families, infants were fed a lactose-reduced formula. And it turns out that almost half of all infant formula in the US is not made with lactose. It's kind of surprising, because lactose, as I mentioned, is the main carbohydrate. It's made with corn syrup. So corn syrup is the main, I know, dietitians are going, what? I'm still saying what 10 years later? I don't understand it. But that is what the infant formula industry did many years ago, under the disguise that babies were fussy and were lactose intolerant. Okay, so they said, okay, babies, even if they are lactose intolerant, we'll take the lactose out and we'll just use corn syrup. It's a bit like pouring corn syrup on your formula if you're lactose intolerant. You just wouldn't do that, right? So, but that's what infant formula is made with in many cases. So, like I said, almost half of all infant formula is not made with lactose, it's made with corn syrup. So we have been doing a series of studies looking at what happens to these infants who were fed these formula. The first study looks at eating behaviors. These are all Latino children. I'll just give you the punchline before I confuse you with the data. The punchline is that these infants consuming formula made with corn syrup develop greater food fussiness and reduced enjoyment of food in the first 2 years of life. This is all survey-based using the baby and infant food behavior questionnaires based on the mother's response to questions, so it's hard to exactly measure. But when we looked at the change, it's a longitudinal study looking at infants at 12, 18, and 24 months. And these are the data in infants who are breastfed, pretty stable. Traditional formula increases a little bit, but we've got a highly significant interaction in the infants who were fed corn syrup. And you can see here, it starts a bit lower, but they become much more food fussy by 2 years of age. And the opposite for enjoyment of food, which is relatively stable in breastfed and traditional formula-fed infants, but significantly plummets, skyfalls in the infants who were fed formula containing corn syrup solids. Starts off pretty high, but just significantly, gradually reduces. The second finding is on gut microbiome at 6 months of age. Now, we're currently looking at gut microbiome at 2 years of age, but here's the 6-month data. Here's just some data. Some examples of gut bacteria that matured early. And the 4 groups, and the most striking data, just look over here, this is the most striking data. This is breastfed at the breast, breastfed from a bottle, traditional formula, and this is the corn syrup formula. And this is one bacteria that we don't know too much about, but the point is that we're seeing emergence of this bacteria in the guts of these infants at 6 months of age, whereas in breastfed infants or breast milk fed infants, this bacteria is not even being produced yet. We'll have to wait to understand more about what that is in fact contributing to in the infants over the longer term. The third study I'll show you was just published this year in the American Journal of Clinical Nutrition in a larger population of infants in a program called WIC. WIC is a federally supported program for low-income families that provides formula to low-income families. And so this study has data on hundreds of thousands of children in the state of California. So we collaborated with them, looked at their data on children between 2013 and 2020. We eliminated all children who were stopped breastfeeding by 3 months of age to just remove that as a potential confounder, and looked at longitudinal data from 15,000 children over 4 years. And the bottom line is that even at 2 years of age, the children who were fed corn syrup-based formula, this is the prevalence of obesity at 2 years of age, 16.2 versus 14.3%. 3 years of age and 4 years of age. At each age, there's a higher prevalence of obesity in those children. You can see the rates are already quite high to begin with, but when they were fed the formula with corn syrup, the prevalence is even higher. And then just lastly, breastfeeding. I showed you this data earlier, the little teaser I gave you. The follow-up to that is that in the same study, in the infants who were breastfed for more than 12 months, you can see much lower levels of obesity, even in those who were highly consuming beverages. Only 9% of those kids were obese versus 24%. So it got us very interested in trying to understand more about breast milk and its potential protective effects. And then we got interested in these complex sugars called oligosaccharides, which are highly abundant in human milk, about the same concentration overall as protein, and they're quite unique to humans versus other animals. They're complex carbohydrates and built off of the lactose molecule. There's hundreds of these different molecules that have different structures. The most abundant is this molecule called 2-fucosyl lactose, which just adds on a fucose residue onto the lactose molecule. These are highly abundant and highly variable, known to play a key role in the development of infant immunity, and they act as prebiotics. They're not immediately metabolized. They degrade in the colon and might contribute to shaping of the gut microbiome, which is something that we're looking at, and might contribute to obesity, feeding behaviors, and so on. This is the first study that's looked at the long-term changes in these compounds. So 2-FL, I said, was the most abundant in human milk, and this is women who were lactating out to 2 years after birth. And this group down here called non-secretors, there's some women who are unable to make 2-FL because of a genetic factor. But in all cases, you can see even if they are making 2-FL, it remains pretty stable. Most of the HMOs reduce in concentration, as shown by these 3 examples. These are 3 other HMOs that fall significantly. But we became very interested in these 2 HMOs because they were the only 2 that significantly increased during the course of lactation. One called 3SL and one called 3FL. And those are the only 2 that increase, and I'm very interested in these to see if they explain some of the dose-response effects that we know about breastfeeding on things like cognitive development and obesity prevention. And so we're looking to see whether these might explain any of those factors. 2-FL is already used as a supplement in some infant formula because it's been shown to enhance learning, memory, and attention in rodents. And it's already used as a supplement in some formula. This is some of the first data that we published looking at infant cognitive development with the Bailey's test at 24 months of age relative to the concentration of 2-FL in mother's milk at 1 month of age. So we see a significantly higher effect, a correlation, higher cognitive performance with higher 2-FL in the breast milk. Interestingly, we only see that based on the 2-FL at 1 month, not on the 6 month or the 12 month or the 18 month. So it may be that very early exposure to this compound may be important. We've done some studies in the magnet. We took babies into the 3 Tesla magnet to try and look at brain development in infants at 1 month of age based on the concentration of breast milk oligosaccharides. And just, I'm kind of ending with the most complicated study, but we looked at various markers from those imaging studies, one which is a measure of brain myelination, and another which is a measure of dendritic branching. And we got these studies. This just shows you, I'm not going to touch you. This shows you 1, 2, 3, 4, 5, 6 different slices of the brain in the baby brain. And the signal on the top is looking at the signal between 2FL concentration in the breast milk and the indicator of myelination. You can see hugely bright lit up all parts of the brain. And in the bottom, specific areas of the brain that were associated with dendritic branching. And so we published this last year showing that 2FL was important for dendritic branching and circuit formation in the brain, whereas 3FL and 3SL, which are similar molecules but slightly different, were more important for enhancing structural connectivity. Interestingly, another oligosaccharide called 6SL, which is almost identical to 3SL, was not associated with any MRI outcomes. That's it. We made it to the end. Thank you so much, and thank you for the opportunity, Grace, and for everybody for coming today. Appreciate you and hope that was helpful. Thank you so much. Thank you.